Hello, welcome to this lesson on queues. So queues are one of the other data structures that we are going to be looking at in this course. So what is a queue? It's basically an ordered group of homogeneous items of elements. So it's basically saying it's a group of similar items. So queues have got two ends, okay? Firstly, elements are added at one end and then they are removed from the other end. So when you're dealing with queues, you need to remember that queues use a first in, first out approach. So the first thing that goes into your queue is the first thing that's also going to go out. Just like any other queue in real life, where the first person to arrive is the first person to also be served and go. So when it comes to queues, when you're creating a queue, like probably you're going to use arrays or you're going to use linked lists to create your queue. So when you're creating your queue, you need to first define the maximum number of elements that queue can take. So this is different from linked lists, where linked lists you can store as many items as possible, but with queues you need to specify the maximum number of items that queue can actually take. Then you also need to specify the data type of the items in the queue. So if in the queue you're putting names, then the data type will be strings. If you're putting numbers, then you could have integers, double, etc. So when you have a queue, what kind of operations can you do on a queue? So this is basically a queue interface showing some of the things that you can do on a queue. So when you have a queue, firstly you can enqueue. Now enqueuing an object or enqueuing something into a queue means you are adding something into a queue, okay? And then dequeuing means you are removing something from the queue. So remember, when you are enqueuing, adding something, you are adding it to the last part of the queue or to the bottom of the queue. And then when you are dequeuing, you are removing the thing that's at the top of the queue. Usually that's the thing that is the first thing. So as you add things at the back of the queue, the things are bumped up and they go to the front. And as you remove, they also continue being bumped up. So you're always going to remove the first things that came in. So it sticks to the first in, first out principle. Then when you're dealing with queues, you can also check if the queue is empty. So you can see with this public void is empty. This is basically a function that is going to check if the queue is empty. So why would you want to know if the queue is empty? If you know if the queue is empty, then you know that there's nothing to dequeue. At the same time, it means that there is a lot of space for you to enqueue stuff into that queue. Then you can also clear the queue. So this can be used to delete all the items in the queue. And as we said, the dequeue part can be used to remove the topmost or firstmost element in the queue. And then the enqueue function is used to add into the queue. So these are some of the various code implementations that you can use. So when it comes to enqueuing, now the two key operations is enqueuing and dequeuing. Enqueuing being adding a new item and dequeuing being removing a new item. So enqueuing, as we said, it adds a new item to the back or to the rear of the queue. Now, what conditions need to exist for you to be able to do this operation? So the conditions that need to be in place is that a queue should have been initialized. That's first. So that means you should have defined that this queue is named Q1 or whatever name, and it takes this maximum number of elements. When you have initialized that queue, it also needs to not be full so that there is space to add something. Then after you have added something, it means that item that you have added is now at the end of the queue. Those are the post conditions that are being mentioned. So as you are dealing with queues, the queue needs to be initialized and it should not full. And after you have added an element, the new item is at the rear of the queue. Then what is dequeuing? Dequeuing removes items. Dequeuing removes items from the front of the queue, okay? And it gives the item or returns it in a different place. So basically dequeuing, we are removing whatever is at the front of the queue. And the conditions that need to exist is that firstly, the queue is supposed to have been initialized and the queue is not supposed to be empty, okay? So as long as the queue has got something and is not empty, you can actually remove something from the queue. Then after you've removed something from the queue, what it means is that the topmost or the frontmost element has been removed, and whatever was second from that element is now the top first element. And if that is also removed, whatever was second to that second element is now also top of the element. And that's whatever you have removed, you can use it for whatever it is that you want. So when you're dealing with queues, you can implement the queue as a circular structure. We'll look at that. And then you need to consider, how do we know if a queue is full or empty? So that's where you have the methods or the various ways to check whether the queue is full or empty. So you can use your various your operations to check, to have functions that check whether the queue is full or it's empty. Then you also need to initialize the queue. Okay, that's very important. There has to be a queue. You need to initialize it at the front as well as at the rear, so that we know whether the queue is full or not. And then we need to test for the full queue. So as you write your operation or your algorithm for dealing with queues, you first need to make sure that the queue is initialized. That's number one. Number two, you need to make sure that the queue is not full or empty. Then number three, you can either enqueue or dequeue. So those are the kind of steps that you follow. So if we look at this example here, it's basically showing some operations of how this enqueuing and dequeuing occurs. So in this instance, we have got queue.enqueue2. So we are adding 2 to this queue. Then we do another enqueue operation, and we are now adding 3. So since we have added 3 and we said all items are added from the array in a queue, then 3, the location where 3 is now the array, and 2 is still at the front. And then we do another enqueue, we add 5. 5 is now at the back of 3. Then we do a dequeue. So dequeue will remove whatever element is at the top, and therefore 2 is removed. And now the element that's at the front is 3. And then we do another dequeue, remove 3. That means our queue now only has the element number 5, and both pointers of front and rear are pointed to number 5. Then if we add another element enqueue, that means 5 is now the topmost element, and 10 is now the element at the back. So what are queues used for? What are the operations that we use queues for? Queues can be used for printers, for network packet routing and switching, and it can also be used for general resource sharing. So whatever comes in first is used first, or is allocated space first, and the like. So we have already discussed the queue operations, the enqueue, the dequeue, the clear or delete elements in the queue, empty the queue, or check if the queue is also full. So in summary, we said queues use first in, first out. Items are added from the back and they exit from the front. And queue means you're adding something from the back, and dequeue means you're removing something from the front. So basically those are the operations that we deal with in queues. And this is generally some code that you can look at on how you can implement a queue as code. So this is some pseudocode that you can use for that. We'll look at that in our lecture. So finally, this is all we have for queues. Remember, queues use a first in, first out approach. They enqueue and dequeue, and the operations you need to check whether the queue is empty, whether it's full, and whether it's been initialized. So thank you for listening to this video, and I hope you've learned a lot.